Okay, section 2 of chapter 6 is just more trig equations. And again, I'm David Dipple from Lone Star College, Montgomery. Okay, suppose you have 2 cosine minus 1 is equal to secant. And we are dealing in radians between 0 and 2 pi. Now, secant, if you'll change that to 1 over cosine, multiply everything by cosine, you'll get 2 cosine squared minus cosine is equal to 1. Then you move the 1 across, you can factor it. So you get 2 cosine squared minus cosine minus 1 is equal to 0. This will factor into 2 cosine times 1 cosine, and minus 1 times plus 1. And you can check it, negative 2 cosine if you do the outsides, and positive cosine, which adds up to cosine. Okay, then if you set each of these equal to 0, you'll get cosine equals subtract 1 and divide by 2 and add 1. Cosine is negative a half, 2 places in the second and third quadrant. So cosine is negative a half at 2 pi over 3 and 4 pi over 3, and cosine is equal to 1 at 0. So we've solved that equation by factoring, setting each of those equal to 0, solving both of those, and looking on the circle between 0 and 2 pi once around. Okay, another example, sine 2 theta, 2 cosine theta, square root of 2 cosine theta is equal to 0. In this case, we're at degrees. Now, sine 2 theta, if you'll do the substitution, turns into 2 sine cosine, plus the square root of 2. Then you can factor out the cosine, and you get cosine times 2 sine theta plus the square root of 2. Set both of those equal to 0. You'll get cosine is equal to 0. And subtract the square root of 2 divided by 2 is negative square root of 2 over 2. Okay, cosine is equal to 0 happens one time at 90 degrees. It's going to be 2 times, and 270. Sine is equal to negative square root of 2 over 2 in the third and fourth quadrants, so it's 225 and 315. Okay, this one we have cosine of 2 theta plus 3 sine theta minus 2 is equal to 0. We can change cosine 2 theta into 3 different things. We're going to pick the one that has sine in it. I believe that's 1 minus sine squared. So it's going to be 1 minus 2 sine squared plus 3 sine theta minus 2. Okay, if you'll change all of the plus minuses in there, so we'll have a positive 2 sine squared. You'll get 2 sine squared minus 3 sine and 1. This will factor into 2 sine times sine, and both minus 1s. 2 sine times 1 is 2 sine. Minus 1 times sine is another sine, makes 3 sines. Okay, set those both equal to 0. This will be 1 half, and that'll be 1. Now, sine is a half twice. And again, we're in degrees, so we're at 30 and 150. And sine is equal to 1 at 90 degrees. Okay, similar situation, cosine squared and a sine. So we'll do the same substitution. Okay, we have cosine squared, which turns into 1 minus sine squared. So you have 4 times 1 minus sine squared, 4 sine minus 5. And this time we're in radians. So 4 times 1 and 4 times sine, or sine squared rather. Okay, again, I'd like my sine squared to have a positive coefficient, so I'm going to change the 4 to positive, this 4 to negative, and that 5 and that 4. Change both of those plus minuses, and you should get 4 sine squared minus 4 sine. 4 minus 5 is negative 1. Change it to positive 1. This will factor into 2 sine minus 1 times 2 sine minus 1. Again, that's 4 sine squared minus 2 is minus 4 plus 1. Now, since those replicate, all you need is pick one of them. Move the 1, divide by 2, you get sine is equal to 1 half, and that happens twice at, since we're in radians, pi over 6 and 5 pi over 6. So that concludes some more examples of solving trigonometric equations, which is section 2 of chapter 6.